Okay, let's go ahead and get started. I'd like to thank everyone who is joining us today. Welcome to the webinar, The Age of the Cloud Native Security Platform. I'm Taylor Wagner, Operations Analyst here at CNCF, and I'll be hosting today's webinar. We'd like to welcome our presenter today, Keith Mokris, the Technical Marketing Engineer at Palo Alto Networks. A few housekeeping items before we get started today. During the webinar, you are not able to talk as an attendee, but there is a Q&A box located at the bottom of your Zoom screen. Please feel free to drop your questions in there rather than the chat window. We'll get to as many as we can at the end. We also like to remind you that this is an official webinar of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or the questions that would be in violation of that code. Basically, please be respectful of all of your fellow participants and the presenter. With that, I'll hand it over to Keith to kick off today's presentation.
Thank you so much, Taylor. Thanks so much to everyone who's joined today. I'm looking forward to sharing everything that's been happening as part of Palo Alto Networks and Prisma when it comes to some of the trends that we're seeing as part of cloud native security. I currently am focused. I've been at Palo Alto Networks 6 months. Previously running product marketing at Twistlock for a little bit over 2 years. So I joined as part of the acquisition, and really excited to talk about how we see container, Kubernetes, and cloud native security evolving across the ecosystem with CNCF. One of the things I want to highlight, and this shouldn't be a surprise to everyone today, is just how dynamic cloud native is becoming. And so the recent definition update that CNCF has posted and this evolution of this definition really shows how cloud native architectures aren't just about private clouds or about public clouds or a single application design. It's really dynamic, spans the entire lifecycle, leverages automation, and uses APIs as part of this approach. And we're ultimately going to be looking at this definition when we come to think about evolution in security today. I don't think I have to go through any of these stats to wow the audience with the growth of cloud native architectures. But ultimately, organizations are using the cloud and cloud native architectures when they build and deploy or re-architect applications today. Certainly, containers, Kubernetes, and serverless are a part of this growth. But one of the things I'll certainly highlight from a visual that I could recognize recently was going to the keynotes at KubeCon US, Cloud Native Con US, and just seeing how big the audience has grown. I've been the last 3 years and seeing, well over 10,000 people in attendance this year really just shows how these tools, architectures, and deployment options that organizations have today has completely, really grown year over year. And ultimately, when we look at security and we look at application architectures today, we see 3 key layers that organizations are using and need to be mindful of when it comes to security. So certainly there are the physical components that make up these these applications, the building, the metal, the silicon, whether you've outsourced this component to a cloud provider or managing it yourself. There's all of the services that you have to use, all the off-the-shelf databases or app servers that are available to your organization. And then finally, we talk about this compute layer, which I'll reference several times today. And this is all of the software, the application, the architecture that you're continually making or building and deploying. And each of these layers involves a specific security responsibility that we really see interspersed with one another. And I'm going to spend a little bit of time on this slide because organizations really have more compute options as part of this cloud native ecosystem than ever before. And one of the things I'll highlight as you move from left to right across the diagram, there are different trade-offs in how your application can be designed, run, or perform. So on the left side of the diagram, you have things like virtual machines and containers that present a greater notion of isolation, compatibility, and control. And as you shift and pivot or move to the right, you gain more density, agility, and simplicity while losing some of the things that you have on the left side. And each of these trade-offs impacts how your application needs to be secured as well. And I'll highlight, some of the things that I think are really important about each of the different compute offerings, certainly from a security perspective. So traditionally, we wouldn't really think of virtual machines as being very cloud native. But as we see more and more organizations, and certainly users in the audience today, probably running virtual machines on the cloud provider more as cattle rather than pets. So with this analogy with a pet, you give it a unique name, you manage it very closely in an individual nature, you nurse it back to health if you see kind of an illness or a vulnerability or an issue. While cattle, you have kind of a naming correlation, you deploy it and manage it with automation. All of your VMs or hosts are pretty identical in nature. And ultimately, you're spinning one up, a new one up with automation, rather than nursing these VMs back to health or maintaining them from an individual posture. And as we shift to containers, I think everyone is pretty aware of some of the notions of container infrastructure that really work in conjunction with VMs. But ultimately, you start to shift to more of a microservices architecture, which allows organizations to build and deploy more quickly. You certainly have a container runtime or container platform that you might be managing as part of your container deployments. And you start to gain more agility and simplicity in how your application is designed. One of the things I like to highlight is as we move from left to right, there are different security ramifications in how you can either gather data via APIs to understand how your application or how your workload is performing, or how you can deploy an agent to gather security telemetry and understand what's happening with your application. So certainly with VMs and containers, the notion of deploying an agent could be pretty straightforward. And then as we shift to containers as a service and on-demand containers, there has certainly been an incredible growth in managed Kubernetes offerings and this notion of event-driven computing in kind of a container-based format. So whether it's managed Kubernetes or AWS Fargate, where you have a task definition, Google Cloud Run, where you have this container-based construct run in a lightweight, event-driven way, or other PaaS services, or Microsoft ACI, you start to get, again, more simplicity in your application design, where you're using some of the existing constructs that already exist that may be very suitable for applications. And then finally, serverless continues to grow as part of cloud native application design. So here you have a snippet of code that can be run in the cloud, can certainly be more difficult to understand from a performance or from a security standpoint. But ultimately, it even provides more simplicity, density, and agility than any of the other offerings. And ultimately, it's all of these different compute options that come together for all of the users in the audience today, or any of the organizations that are re-architecting or deploying modern apps. And all of these different compute offerings, in a lot of ways, can make security harder. And if you think about all of this infrastructure, there are a lot of abstractions to keep in mind. You have the underlying host OS, you may have a container platform, you may have a networking plugin, you have Kubernetes to potentially manage. Even if you're using managed Kubernetes, there are certainly security concerns that you still have to keep track of. All of these abstractions can be a lot to manage and understand, certainly from a security posture perspective. At the same time, the notion of cloud native applications really means that everything is ephemeral and constantly changing. So you're not just handing an application over to the security team and saying, go secure this application. You're constantly redeploying and managing these applications with automation. And that also can be a challenge as you have many more entities to secure. And this is part of the definition of microservices. I'm taking a larger application and I'm breaking it down into declarative, minimal, distinct components. And so you may have, builds that are occurring multiple times a day, multiple times a week. The same with deployments. Your container registry, for example, may have hundreds, if not thousands, of container images, potentially even spread across multiple registries that you need to keep track of. And often organizations aren't just using a single cloud provider or a single platform. There's a lot of infrastructure to keep track of, with security being a big part of that across a lot of different resources. And ultimately, it's the developers and DevOps teams that play a large role in security. They're the ones who are architecting the applications, building and deploying these applications, and ultimately can be very difficult for security to understand how they can work with these teams at scale to really ensure that everything is secure. And this portability that we've already highlighted in a couple of areas really means that security needs to also embrace this notion of portability. And these are all challenges that are really difficult, but also do present some notion of opportunity to really reinvent security in a cloud native way. There are also opportunities to really make cloud native easier. And so one of the things I'll highlight is kind of the nature of cloud native applications that allows for a new approach to security. And cloud native applications really have these three key characteristics. So one, they're often declarative. They're single process entities where you can really understand how they're expected to behave. Again, by definition, microservices applications, certainly serverless applications, are very minimalistic. So there's not as much code to scan or not as much code to dig through to understand how the application will behave. And that really supports this notion of predictability. If I run an application on my desktop, I can expect that it's going to run the same wherever I decide to run it in a public or private cloud instance. And because of these characteristics, we really think there's an opportunity to implement security that's more automated, efficient, and then app aware. And these are all requirements to secure cloud native applications at scale. We really want to highlight how compute is one of these layers. And where some of these characteristics really come into play. And so there's certainly this notion of interdependence and shared risk, with one of the key challenges for the compute layer being low visibility or low understanding. So how do I understand the vulnerability status of my running application? How do I understand what services it's connected to that I'm responsible for managing? And all of these shared components mean that there could be shared risk. It's pretty rare that you just deploy one container that doesn't communicate either to the outside world or to other microservices or databases or other cloud components. And understanding that risk as you continue to scale can be very difficult. And as we mentioned earlier, all of these various abstractions makes it really difficult for a single human to understand it all at scale. It's really difficult if you're not leveraging automation to build a baseline of application behavior to understand how an application is running or performing. When we look at the cloud provider shared responsibility model, we want to highlight that nothing is secure by default, and all of these components that you're responsible for are certainly something that you need to look at from a security perspective. So the cloud provider certainly needs to manage the databases, the data centers and services that they're responsible for. At the same time, that doesn't mean you can avoid the other two layers of the stack. You certainly need to ensure that you've configured all of these components securely, and everything that you have running on them, the workloads and applications that connect to those services, are secure. And there are certainly silos today that have emerged that we see as potentially opportunities for convergence. So again, the bottom layer is still the cloud provider's problem, and they still have a responsibility to ensure that the data center and services they provide are secure. At the same time, when you look at all of these services you're running on the cloud provider, it can be really difficult to understand the current configuration status and how you can monitor all of those together at scale. And there's really been this emergence of the market cloud security posture management that's focused on continually auditing and monitoring all of the cloud provider services you have at your disposal to understand their security posture. And then when it comes to the workloads and applications, cloud workload protection, refers to how do I protect my applications that are running and potentially looking at vulnerability management and compliance status of the components that I'm building. And even beyond that, earlier in the application lifecycle, how do I understand all the open source licenses that I'm using that are part of software component analysis? And how do I understand any initial vulnerabilities or compliance issues that are part of my source code? And so when you look at the cloud provider, responsibility model and where we fit in, as users, how do I then look at the different tools and market silos that are available to ensure that I'm securing my application in its entirety? And this is where we really feel that we've entered the age of the cloud native security platform, where there are all of these different components that can potentially converge and come together to bring together all of these requirements. And so when we look at the notion of a cloud native security platform, the one essential requirement is that security needs to be implemented throughout the development lifecycle. You can't just scan an application once as you're building it and assume it's secure when you deploy it, just like you can't just secure the application when you deploy it. Security needs to be something that is continuous and embedded as part of every build and deployment workflow. And at the same time, there needs to be a comprehensive set of capabilities across layers that can also be available across clouds. And again, this could be public, private, hybrid scenarios, or even on-premise environments that you have. And at the same time, you need to make sure everything is app aware. While there's a lot of data that you can pull from just one of the layers that you have at your disposal, you need to ensure that you're getting visibility into the actual workloads and applications that you're responsible for managing and securing. And ultimately, there needs to be an API for everything. Because workloads and applications are so portable and everything is moving and being deployed so quickly, having APIs that can stitch everything together or provide data exactly where it's needed really becomes essential. And so when we map, broadly CNSP capabilities, these are the exact layers that we're talking about. So the capabilities that really look at how we've configured all of the cloud services at our organization, and then how do we secure everything that we have running on top of them. And ultimately, this process becomes continuous across the application lifecycle. So integrating security, for example, as part of regular CI workflows, where not just security gets information about the current vulnerability or compliance status of a container image, but also feeding that information directly to the development and DevOps teams. So you can quickly understand, am I deploying a secure application to the environment based on the environment requirements that are part of my organization's risk factor framework? Or how do I ensure that if I'm running an application on top of Kubernetes or with Kubernetes, that I've securely configured container to container traffic to that new connections can't be created or that I'm not introducing a threat scenario. And at the same time, for any of these applications that connect to the services that are part of my cloud provider and how I've configured them, am I continuously ensuring that none of them are configured and being run with insecure defaults, or there isn't a change in a status of any of these services that would really implement me from a security and risk perspective? And when we see, the reason we see, a real market convergence around CNSP is because of a lot of these reasons and challenges. So a lot of current tools may have kind of a single lifecycle phase focus. So they may be really good at only looking at, issues at build time, or issues in the registry or a certain runtime component, which certainly provides limitations in how you can update these tools and the global visibility you may need. Oftentimes, tools are manually intensive, and this can be a real challenge when you want to avoid rule rot in order to protect cloud native applications at scale. If you're on the security team, being able to gather real-time intelligence and protection that you don't have to configure from a baseline perspective provides incredible advantages. Certainly, organizations care about protecting the app and its data, but a lot of tools are built to protect just one layer of these components, while you really want this full stack approach. Certainly, we see a lot of security product fatigue where organizations are constantly swapping tools or having difficulty in maintaining them, which again is another challenge at scale. And then at the same time, as organizations have really embraced multi and hybrid cloud infrastructure, if your tooling isn't built to provide consistent security across all of these different environments, you can be really challenged in how you can understand risk posture across a disparate set of environments. And that's where we really believe security needs to be aligned to the definition of cloud native. And that's where we started in today's presentation. So certainly integrating security across the application lifecycle is key, and doing this in a continuous automated fashion is a core requirement and framework. And so being able to implement security as part of these modern CI/CD workflows, whether they're leveraging cloud provider or third-party tooling, becomes incredibly important. And making sure that security can integrate with a combination of all these components is really essential. We talked about this earlier, but I'll emphasize it again. Because so many organizations are running components in so many different places, we can't have a dashboard for everything. And so making sure any security telemetry or any component that we want to look at can be accessible via the API is essential as organizations look to tailor all of these capabilities for their specific use cases. And because those APIs are the backbone of cloud native infrastructure, a cloud native security platform needs to be fully accessible via APIs. And then finally, we've highlighted this today a bunch, but being able to run security anywhere across all of the different compute frameworks, whether it's hosts, whether it's containers or serverless applications, is truly essential. And there can't be excuses there because those blind spots can really create problems in understanding consistent risk posture. And so when we look at some of the capabilities that we think are really important, I'll certainly highlight a few here. We ultimately think it's the community that should be driving this definition of a CNSP across all of these capabilities. And I'll highlight a couple that I think are becoming more and more relevant based on the market's evolving nature. Network security, when it comes to cloud native applications, is an incredible challenge. And it really comes into first visibility. How do you understand how all of your containers or microservices are communicating with one another? And are they communicating in real time in a clear way that you would expect? Then that can evolve to look at how do I enforce safe traffic flows across boundaries like namespaces or even connecting to a front-end microservice. Vulnerability and compliance management certainly go hand in hand, and these should be part of a continuous process that any organization is implementing. So can I quickly understand the risk and compliance posture of all of the applications that I have deployed at a global scale? And then can I be very granular in looking at a container image I've built and understand, does it meet the CIS benchmarks that I think are really important or my organization has set as key security standards? And does it meet any of the vulnerability policies for a specific environment? And can I quickly remediate any risk that's present in my environment? We certainly highlighted CI/CD integration, and being able to implement this security in a powerful way really offers organizations the ability to ensure that they're deploying code to the environments that they're looking at in a secure fashion. And one of the capabilities that I'll highlight that should be part of CI/CD is not just visibility into vulnerability and compliance issues, but also the notion of policy enforcement. So for example, if I'm going to deploy an application into a production environment, can I set granular thresholds or guardrails around what can be deployed there? So for example, setting up a rule where I'm going to block a vulnerability with a vendor fix and make sure that my development and DevOps team can fix that before I've deployed. There are also a handful of capabilities that go hand in hand with one another. Things like runtime protection and automated response. Can I protect a running application by using things like application control and whitelisting, where I build a baseline of application behavior, And then if something anomalous happens, not just alert to that, but actually prevent that bad action from happening. And if there is some sort of a data breach or some sort of a security incident, can I quickly gather forensic intelligence, store that securely before my environment is impacted, and then pass this vital intelligence to the right people at my organization to understand how my applications or workloads are impacted. And so it's ultimately all of these capabilities that we think come together across the service layer, across the compute layer, and the application lifecycle that provide organizations with a powerful new way to protect their applications at scale that are really part of how cloud native applications are being designed and deployed today. This really brings us to our old world meets new world approach. So in the old world, we could only really protect applications in production only. There was this notion of handing the application off to the security team and making them worry about the application at runtime. This really creates a lot of silos for each individual layer of the stack. Obviously, in the old world, there was this perimeter-focused security model. You certainly still need to protect your perimeter today, but you also need to make sure that you can look at all the individual application connections themselves in real time to understand how they're behaving from a network, security posture, certainly. And then we've certainly seen a shift from everything being manually operated to everything now being automated and API enabled. And so that's where we really transition to this new world approach, where we can use automation, focus on all of the applications themselves, and bring all of these components together across both the life cycle and from a platform perspective. And so this really brings me to my conclusion today. I want to say a huge thank you to everyone who's tuned in, either live or will in future on demand, and ultimately certainly have a couple minutes for questions. We're really excited to see, the continued growth throughout the cloud native ecosystem, and really excited now at Palo Alto Networks to be a part of it.
Thanks, Keith, for that presentation. If anyone has any questions, please pop them into the Q&A box located at the bottom of your Zoom screen. Let's give it maybe a minute or so, see if anybody has any questions. Well, we don't seem to have any questions, Keith. So maybe we just wrap this up. Thanks again for such a great presentation. The recording and slides will be online later today at cncf.io/webinars. And we're looking forward to seeing everybody again at a future CNCF webinar. Have a great day.
Thanks, everybody.